All right, we're going to start chapter 10 here today. Circles. So changing gears a little bit. I think hopefully for everyone it's a nice change up, coming off some of the trigonometry stuff that was maybe a little bit tougher. A little bit shorter of a chapter as well. Only a couple lessons. We'll try to do a quiz like we did for the last chapter. Maybe two quizzes as far as first half of the chapter, second half of the chapter. So keep plugging away, follow along, have your notes. I think it's a good idea to not only have the video, watch the video, but to maybe do some of the problems so you can get actual physical practice of doing them versus just kind of watching somebody else do them. So I think we'll just jump into it. I'm going to try to keep the videos shorter with the understanding that you can obviously go back and watch anything. So I might go quick, but that's just me trying to maybe keep the videos a little bit shorter. So I think let's get into it. We'll look at all these different stuff. Some of the stuff I know you've heard of before, as far as some of the terminology. This first lesson, 10.1 in particular, has a lot of vocabulary that we're going to use for future lessons. But I guess the good part is at least the first portion of the vocabulary I'm confident that just about everybody has heard of in previous courses. So we'll get into these special segments and lines in a circle. That's the part that I think a lot of us know. And then we'll look at this idea of tangency, a segment that is tangent. So first thing, some of the vocab. There's not a whole lot to do other than just make sure you catch this. This would be the stuff that, again, just going through the process of maybe adding it to your notebook or whatever, rewatching this section just so you can kind of hear it. I'm going to try to avoid reading as much as I can, but give you a little bit more insight because I understand that you can read what's going on here. So properties of circles, that's the name of the chapter. Here's what we got. So what is a circle? Let's start with that. A circle we haven't talked about it yet because it's not a polygon. It doesn't have sides. It's really a collection, a set of points that are all equidistant from a given point, which we call the center. Okay, the center is the point which all points are equidistant from. So if we call point P here the center, every point along this green line is the exact same distance. This distance, this distance, this distance right here, all the exact same distance. Okay, and it's that infinite amount of points that when you put them all side by side, they create what we just think of as a circle. All right, a segment or the radius, that distance that we were talking about from P to the circle is what we call the radius. That's a term that hopefully everybody's familiar with. Yeah, from center to the circle. Okay, and if I put two radii together, so that radii is plural of radius. So we could think of from right here to here as a radius, and right here and here as a radius. When I put those together and create really a segment that passes through the center, we get a diameter. Both of those are terms I know you're kind of familiar with. We'll come back to this one right here, chord, in a second. But basically a segment that passes through the center of the circle with endpoints on the circle, that's what we would call a diameter. Okay, so it's really a radius times 2, or 2 radii put together. I think one of the most important takeaways here from this slide is just naming and saying a circle. So this is what we would call circle P. We name them using the center. So the fact that this is just called point P means that we would call this circle P. And then abbreviation-wise, to avoid having to write this out all the time, we can use just a tiny little circle with a center in it, P. Okay, so we would still say circle P when I see this abbreviation like this. Okay, so just like everything else, we've got a lot of abbreviations. We have an abbreviation for a circle. So that's some of the just intro vocab: center, radius, diameter, and then what is a circle. It's really continuing. These are the ones that I think are a little bit tougher. They're just not as familiar for us. Chord, let's start with chord because it came up on the previous slide. A chord is a segment. Remember segments here? I'm going to do a little bit, just hopefully a review for us, and maybe even put some points on here just so you can kind of just review this here. Let's call these, let's put some points to these here. So like A and B. A chord is a segment whose endpoints are on the circle. So I've got endpoints right here, A and B. So we would say an example of a chord in this figure would be, remember the abbreviation, segment AB with just the line above the top of it, so that would be a chord. On the previous slide, the example that said diameter, it's just a shorter way of saying it, is a chord that passes through the center. So we still have endpoints here and here. It's just a chord that passes through the center. Okay, so that's a chord. Tangent, okay, let's switch over here to red. Tangent would be, I'm going to put another point out here. Let's call this DC or CD. So a line, ray, or a segment, basically any line portion, a line, array, or a segment that intersects the circle just in one spot, okay, which we call a point of tangency. So we have, so for us, if I were going to say, hey, you look at this picture and name me something that's tangent to this circle, our only answer would be line with the arrows on it now, line DC. You could say line CD. Remember, we could flip this and say CD. This is going back all the way to chapter 1, so that's why I'm reviewing it here a little bit for us. You could say ray CD would be another example. Maybe let's put one more here, just because there's a few answers, I guess, for this one. I shouldn't say the only answer, but so ray CD, okay, would be starting here, going forever that way, ray CD. And the reason I know it's tangent is because it's only intersecting my circle one spot, point D, which we call a point of tangency, okay? The other one, I know you're looking at tangent before I move on. We just got done doing SOHCAHTOA tangent, not really connected to that. For us, let's just chalk it up as coincidental that we're calling this tangent. We're not doing anything with SOHCAHTOA or anything like that, okay? Last one, secant, is a line, or I guess a ray, that intersects the circle in 2 points. So let's call this points E and F. So our example of give a line that is, or give a line that is secant to the circle, you would say something like line EF, okay? Secants and chords are kind of tricky, and sometimes people get them mixed up because by doing that, by adding some points here, basically we can't have a secant without a chord, right? There's a chord here. There's chord EF. So now you're thinking, well, what the heck? We put EF in 2 different spots, but remember, we're talking about 2 different things. When I write it like this and say segment EF, I'm only talking about from right here to right here, just this portion of that line. That's what makes it a chord. It's endpoints. It's a segment whose endpoints are on the circle, versus a secant, line EF, which it is this, but also this forever and this forever. Okay, so there's a difference there. They're easy to get mixed up, chord versus secant. Okay. So we'll take a look at a few examples here. Like I said, I'm going to try to go quick here. It's just it's a straight up vocab check. So tell whether the line, ray, or segments, you've kind of got a list of just lines, rays, and segments here. Give the vocab word that best describes it. Okay, so it's a little bit, that's why I was reviewing some of the notation there and make sure we're paying attention to that, because it matters what we're talking about. So this is talking about just segment BC. Where's segment BC? So from B to C, just this segment right here. I would say the best word for that would be a radius, right? Center to the edge of to the circle. Let's look at line EA. Okay, so line EA starts here, goes through here, and it goes forever. So it continues forever and ever. How many times is this line? My pen is kind of hard to use here. Our line intersects our circle 2 different spots. So our line, let's see if I can clean that up a little bit, that intersects my circle twice. I would call that a secant. I would say is the best word for that. It's a line, it's continuous, and it intersects the circle 2 different spots. Okay. Ray, DE, now DE, like with a ray, this could be multiple things. It could be a secant. I guess a line could be either a secant or a tangent. This could be a secant or a tangent. Chord, a segment, you've only got a couple different options. Radius, diameter, or just chord. All right, so let's let's look at ray DE, starts right here and goes forever this way. So it's just a ray, but how many times is it intersecting the circle? One spot. So I would say this is a tangent. As like a follow-up, if I wanted to be more specific, if one of my questions was point, you know, what word best describes point B, I would say that is a point of tangency. Okay. Last one. This definitely isn't hitting everything. There's words that just aren't getting used. Segment FA. So I got to look. I got to find it. It's segment FA. It's overlapping. It goes from here to here. So just the segment. We just got done talking about this. We're not talking about all this red out here and here. It's just the segment. This would be a prime example of a chord. Okay. So I'll kind of do what I've done for some of the other homework. You're just going to go side by side. This first 1 through 10 really, there's a matching section with some of the stuff we were just looking at. It's in a few up here that just goes straight, just vocab practice. Okay, so this is what your homework will look like, worksheet 10.1. We'll go back and forth just so there's no confusion. Along with, which I guess this would be the next section of the homework, you can kind of see there's a picture that looks just like this. Lengths, measurements, okay? The way I can ask you without, you know, breaking out a rule or anything like that, I've got a couple circles here, and this is kind of a tricky figure because you've got circle A, you can kind of see here the radius of circle A with center A, and then you've got a bigger, it's inside a bigger circle with center B. So different centers, different circles, one just happens to be inside the other. So it's kind of just picking the picture apart a little bit here. The radius of circle A, remember, is the distance. How can I find this distance? Well, I probably don't want to pick that and try to figure out how big that is. Right? That is a radius, but I don't want to use that one. I would much rather use this radius right here, or this radius right here, or this radius right here, because I can count them. How long are these radii? 2 units. So is this one. I never would have got that if I were just trying to count. Right? So that's the advantage of kind of going north, south, east, and west there. I'm going to take those off, some of these extra ones, but if I'm sticking with, we can leave this one here, I guess. The diameter of circle A is now, all right, the diameter is a chord that passes through the center. So 1, 2, 3, 4 units. And I think a lot of us we understand that a radius and a diameter, that's the relationship. If I double the radius, I get the diameter. Okay, changing circles here a little bit, so we're almost going to kind of ignore everything that's going on with A here and just look at circle B. So now starting at B, what is the radius? Let's count it. 1, 2, 3, 4. Okay, no problem. And what we just talked about, without even counting, I should hopefully be able to figure out, and I could count it again, 4, 5, 6, 7, 8, that my diameter of circle B is 8. Okay, so just a quick check of radius, diameter, and putting some numbers to it. So on the homework, just watch, and I wrote it here, I just don't want you to miss it, watch the scale. Okay, so this scale isn't going by 1s, it's going by 3s. There's one other question here that we got to talk about, there's common tangents, which will come up right here as well. So 13, 14, 15, 16 all involve this concept of common tangents. So another note here for us, when we start to put, and we were kind of just looking at it, 2 circles together on the same plane in the same picture in the same figure basically, there's really 3 ways that they could kind of interact. They could either intersect twice, like we're seeing here, they're overlapping, they're crossing in 2 different spots. Okay, not a fancy name, it just has 2 points of intersection. Another situation would be they could intersect in 1 spot. Okay, we haven't seen this yet, but you know, we're seeing a circle inside a circle, and they're actually touching. They're touching in that 1 spot. Or they're not actually one's not inside the other, but they're still touching. They're kind of separate, 2 separate circles. They're outside each other, but they just happen to be touching in that 1 spot. We would say those are tangent circles. Okay. And the third situation would be that they don't intersect at all, right? They're just 2 completely separate circles, like this one and this one. We just saw some where circle A and B didn't intersect. There is a word here called concentric circles. That's actually where they share the same center. Okay, that's not the situation, right? They had different centers. A was a center, B was a center. They didn't intersect, so that still kind of falls into this category of non-intersecting, no points of intersection. But this would not be concentric because they don't have the same center. Okay, so there's a lot of vocab flying around here. That's why I said pause it, maybe add some of that to your note. The word that comes up on the homework and that we have to know as well is common tangent. So a common tangent still goes back to this: what is a tangent? It's a line, array, or a segment that intersects the circle in exactly one spot. Common tangent just is, now, and we have some drawn here actually, right here and here, a line, array, or a segment that you could draw that's actually tangent to two circles. Okay, is this purple line tangent to this circle? Yep. Is it tangent to this circle? Yep. It's still just a single line, but it's tangent to two different circles. Same thing going on here. Okay. I have one here. I'm not going to do all these because I have you practicing this on the homework, and I don't want to just say here's all the answers type of thing, where we kind of look at some of those different situations. We have a single intersection of two circles, a no intersection of two circles, and another situation with no, but you can kind of see after we do an example here, some of the different ways that these circles could intersect, or we could have common tangents. So I'm just going to focus on B here because this is I think the only one that you don't have on the homework. These other situations you'll practice on the homework. Okay. So if I have, it's asking me to tell how many common tangents the circle have and draw them. I think it's going to be easier to draw them first and just count them up. Okay. And it's going to vary depending on how your circles are situated. So like right here, it's not going to be perfect because I don't have a straight edge, but I'm pretty confident that I could draw a line, array, or a segment that just touches this circle and also just touches that circle. There's an example of a common tangent. Okay, can we draw another one? Sure. I think this side, we could kind of get that same, and I'm trying to do the best I can to keep it non-curved, non-rounded line here, but yeah, I think we can do that same thing and get a line or a point of tangency here and here. It's just a single line, and it's just touching there and there. Okay, so I'm up to 2. Are there any other ones? Let's see here, and you can kind of play around with it. If I were to draw one here, let's see, let me back that up. And say, you know what, I bet you I can draw one right there and say, hey, look at that, it's just hitting this circle in one spot. Well, what's the problem with that though? We're intersecting this bigger circle there and there. It's not tangent to the big circle. So I have to take that one off there. That's not actually one. I think I've kind of exhausted all possibilities here. So this is an example that there's 2 common tangents. Okay. I'm going to let you kind of explore those other ones. There's 4 here, and so there's one that's not going to show up on the homework, but you've got a couple of them right here where, go ahead, I'm asking you to do the same thing. Draw them and tell me how many there are. Okay, and it's going to vary. It's not always 2, it's not always 1, it's not always 0. It's possible to have 0, so I'll let you kind of look at that. All right, the last portion of this, you can see I'm only got 1, 2, 3, 4, 5 more. It's really just kind of 2 notes and a couple examples that go with them. Okay, so I think let's try to keep this keep it a little bit shorter than some of the other ones. Let's finish this up. So the first kind of theorem that we look at, it's just not a fancy name, theorem 10.1. It's still kind of continuing that idea of a line or array that's tangent to a circle. It basically says that if you have a line that's tangent, so line PM, let's put a little point here so we can see it. Line PM, or no, that's not a point. Line M, in PO, that's fine. Line M is tangent to the circle. If we were told that, if we knew that, if a line is tangent to a circle, then I know that the radius of the circle is perpendicular to that tangent. Okay, so you could do kind of the same thing if I put a separate, not so great line over here that I knew was tangent to the circle. I would also know that if I drew the radius, it would be perpendicular to that tangent. Okay, so we've done a lot with perpendicular this year. We'll look at a couple examples here as far as what can we do with this information? How does this help us? And there's one, I think, one easier versus kind of shorter, or easier versus tougher example. So let's take a look here. Example 4, and this kind of just flows if we're going just in direction here. This will be the next set of problems, 17 and 18. So in the diagram, so we got a figure here, circle R, because that's the center. Circle R. It's more of a question. RS is the radius. Okay, fair enough. Is ST tangent? Okay, so we don't really know if this was tangent. This would be a right angle right here. But it's not phrased that way. It didn't tell us that TS was tangent. It's more of a question of, is ST, segment ST, tangent to circle R? Now I've got some really helpful information here, and I'm essentially looking at a triangle, okay, just kind of from this point T out here. I know that TR is 26, I know that TS is 24, and I know the radius of the circle, RS, is 10. So if all this is true, which we're assuming it's true, in order for this to be a right angle, what would have to be true? Well, we're coming off a chapter where we worked really exclusively with right triangles. If this is truly a right triangle, which we're hoping it's going to be, or we're not necessarily hoping, but we can prove that it either is or it isn't, if 10 squared plus 24 squared, if that happens to equal 26 squared, then I can promise you, I can guarantee you that this is a right triangle. Therefore, yes, ST is tangent to circle R. Okay, so I have to kind of crunch the numbers. So get your calculator out. I've got 26 squared. I'm just starting with this side for whatever reason, is 676. And then I can go right on here, 10 squared. You can't see it, but I'm typing this into my calculator. 10 squared plus 24 squared equals 676. Does that always happen? No, it's just that's the way that this one worked out. So I can promise you, I guarantee you that yes, this is a right angle. I've got some work to justify it, not a ton of work. But let's make the conclusion. Is ST tangent to circle R? Let's say it. Segment ST is tangent to circle R. Okay? So there's really our conclusion. And I've got some work to justify it. Okay, don't just say this. You can see it right on the homework as I say it. Determine whether it's tangent to circle C. Your work must justify your conclusion. The one that's tricky, and this is one of the main reasons I'm doing this right here. This, let's see if I can do this on here. Need my pen. This 10 right here, let's say is referring to this whole length, because that's going to make a difference. Okay, so I'm going to say that this whole thing is 10 like that, so that would make 5 and 5. So just point that out in the homework. Okay, so just when you see that this whole length is 10, so you got a 5 and 5 piece, if that helps you. All right. Let's move ahead here. No new concept, but I think this one is like significantly tougher than the one we just looked at. This is probably the hardest problem that you do from lesson 10.1. It's kind of the same question. It's basically, it's using the same concept that point B is a point of tangency. So it's kind of reversing it a little bit. It tells us that point B is a point of tangency. So AB must be tangent to this circle. So that first sentence there, this is a point of tangency, indirectly tells us that, oh, hey, by the way, that segment AB that's tangent is perpendicular to the radius. Okay, find the radius. Now here's the issue now. This 49 is from here to here, right? Obviously this length can't be just 49 because it's got to be longer than 77. So I can't just use 49 for this right here. There's an unknown length, which we're trying to find really, is this radius right here and here. What are we going to do? I'm going to kind of just re-sketch that triangle real quick, just so I can see it, where it's basically, we're looking for radius here. I know that this other leg is 77. How long is this hypotenuse that we're actually, is really unknown? R plus 49, right? It's that same radius plus 49. Okay, so that's really the triangle that we're working with, and that's tough. How are we going to solve this? We can use the Pythagorean theorem. but this is going to make things dicey. So follow along here with me on this. If I go a squared plus b squared equals c squared, this can be my a, this can be my b, this has to be c. So a squared, r squared, plus b squared, so far so good. So okay, I can do all that, equals c squared. This whole thing, r plus 49 squared. And there, right there, is what's going to make this problem tougher. Left side, let's just get this kind of to where we want it. R squared, what the heck is 77 squared? No idea. 5929. Okay, fair enough. It's this right side, where I'm almost going to do like a separate problem over here. So as I go to kind of, let's see one that we can see. R squared, or R plus 49 squared. This does not work by me just dropping this squared here and here. You will be incorrect if you do that. Do not do r squared plus 49 squared. No, no, no. How does this work? What does this actually mean? It means r plus 49 times r plus 49. That's how you square something, right? You multiply it by itself. Oh, yeah, we've seen this before, right? A long time ago, but we've seen and done this. R times r, r squared. R times 49, 49r. 49 times r, well, there's another one, 49r. And then this last one, 49 times 49, get your calculator, 49 times 49 is 2401. So that's, sometimes people call that FOIL. That's how you got to approach this problem. I can't go for right from this to r squared plus 2401. You're going to miss this middle term. The last thing I'm going to do, and I guess I'll just bring it over because I'm kind of running out of space here, would be to combine these like terms, right? This 49r and this 49r. So when this right side gets simplified, we end up with r squared plus 49 plus 49 is 98r plus 2401. That's the work portion of this one right here. And you're looking at this now and thinking, oh my gosh, I got these r squareds, what's going on here? It's actually not as bad as it seems. If we can get to this spot, we're actually in pretty good shape. Let's start getting stuff together. The first thing I would look to do is let's combine this r squared and r squared. What happens? How would I move this to the other side of the equation? Showing my work, I would subtract an r squared from both sides. Well, that's kind of nice. That's a minus r squared. R squared minus r squared cancels. R squared minus r squared cancels. So we're left with, all of a sudden, something that looked kind of not so nice. Those squareds disappear. And we're left with 98, you know, a linear solve here. So how would we finish this? You all know how to do this. Subtract a 2401 from both sides. I'll show it. 2401. Okay, so we're left with 98r on this side, 59, 29 minus 2401. I'm left with 3528. Whoops, hold on, I screwed that up. Minus, yeah, 3528, sorry. Okay, so subtract from both sides. The last thing, let's see if I can scroll down just a little bit here. I don't want to lose too much of the problem. Would be to divide both sides by 98 to get, hopefully, something, and I think they work out clean. Look at that, 36. So this is definitely one, kind of, if you take a step back and just look at the work here, find the radius of this circle. Oh, okay, yeah, sure, not so bad. That's just how it's going to work out. That's how we got to do it. So there's a little bit of a FOIL going on here and some old school algebra solving for an unknown. Okay, so we end up, that's our final answer. R, the radius of the circle, is 36 units, whatever we're talking here. So when you see it, when you're looking for it in the homework, you're going to see them right here, 19 and 20. Numbers aren't so big, so maybe it'll be a little whatever. It won't be as bad, but that's how you got to do it. Okay, that's why there's all this space here, because that's how you're going to do those problems. 2950. Can we finish this up? Let's do it. All right, last concept, 10.2, and I think it's a good one to finish with. It's an easier one. There's not a whole lot of ways to jazz it up. If I've got a point, so basically what this says, from an external point, okay, so I've got point S out here, and I draw a segment from that point to a circle, and I hit it, and I'm just tangent, okay? So this is tangent, going back to the last concept, okay, that's tangent to the circle, and from that same point S, I draw a separate segment, which is also tangent to the circle. What has to be true about those two segments? Could I draw any more from S? No, right? If I went up too far, I wouldn't hit the circle. If I brought it in a little bit, I'd intersect it twice. So those are the only two points, only two segments we could draw. What has to be true about them? These have to be the same length. There's no way that it couldn't be, right? So that's the concept there. So I think it's a relatively easy one to wrap your head around. It's a very, just make sure you read the directions, kind of understand what's going on here. It's kind of a little bit of a setup. So it's telling us that QR, so segment QR is tangent to circle C at point R. Okay, I like that. And then also QS is tangent to circle C at point S. Okay, so that's kind of the information that you need to know in order to say, okay, I know that this, oops, dropped my pen, this has to be the same length as this. So it ends up being, a relatively, I think compared to what we just did, kind of a nice solve, right? Show your work, old school, 3x equals 27. X equals 9. Could I check it? Sure. 9 times 3 is 27. 27 plus 5 is 32. Yep, checks out pretty nicely. X equals 9. Did I answer the question? Find the value of x. Yep, x equals 9. So not terrible solve. Those are the last couple. There is one here. It's going to be the setup. I'm going to let you, and again, I know I didn't do it like this. Can we handle this x squared? It's going back a little bit. How do we solve that? But I think you guys can figure that out. Okay. So there's the homework. There's the lesson. 30 minutes, not terrible. Please reach out to me with any questions. Make sure you're watching the videos. I know I'm at the end here, and if you're not watching the videos, you're not going to hear this, but it's a pretty typical chapter as far as we'll do kind of a lesson. There's no parts like part 1, part 2. Like today is 10.1. The next lesson will be 10.2. Single day, single worksheet. We'll probably break after that, do a short quiz, and then finish the chapter. Okay, so there's 10.1. Get that worksheet done, submit it, and we'll keep moving forward. All right.